Hello everyone, this is Kavinesh from ADS department. We will see A star search algorithm in this PPT. A star search algorithm to find cost effective path source node to goal node. Here A is source node, G is goal node. Numbers written on the edges represent the distance between the node G of n. Number written on the node represent the heuristic values h of n. The heuristic value estimates the cost from the node to the goal, while the path cost represents the actual cost from the start node to a given node. F of x equal to g of n plus h of n. Here we will see how it works. From A we can reach B and E. Compute f of x from each of them. From A to B, f of x equal to g of n plus h of n. F of x equal to g of n value equal to 2 plus h of n value 6. 2 plus 6, f of x equal to 8. From A to E, f of x equal to 3 plus 7. The path cost 3 plus 7 equal to 10. F of x equal to cost. Since the cost for A to B is less, moving forward with this path. Now from B we can go to C and G. So we compute f of x for both A to B to C. So we can add previous cost. F of x equal to 3 plus 99. The cost 99. F of x equal to 102. Now we calculate the A to B to G. F of x equal to 11 plus 0. Here the path A to B to G has the least cost 11, but it is still more than the cost of A to B. Thus we further explore this path. Now from E we can go to D, so we compute f of x. A to E to D, f of x equal to g of n plus h of n. F of x 3 plus 6 plus 1. F of x equal to 10. Comparing the cost of A to E to D with all the paths we got so far, and as this cost is least, we move to cost forward with this path. Now computing f of x for the children of D. A to E to D to G. F of x equal to g of n plus h of n. 3 plus 6 plus 1 plus 0. 10. Now comparing all the paths that lead us to the goal, we conclude that A to E to D to G is the most cost effective path to get from A to G. Therefore, principles behind A star search algorithm. Heuristic function h value. A star uses a heuristic function to estimate the cost of reaching the goal from a given node. This function is admissible if it never overestimates the actual cost. Total cost f value. A star evaluates nodes based on their total cost, which is the sum of the path cost from the start node g value and the heuristic value h value of the node. Priority queue. A star maintains a priority queue of nodes to expand with the node having the lowest total cost at the front of the queue. Practical application and significance of A star search algorithm. Pathfinding. A star is commonly used in pathfinding algorithms such as in GPS systems, video games and robotics to find the shortest path from one point to another efficiently. In robotics, A star is used in robotics for path planning of robots to navigate environments with obstacles. Network routing. A star can be used in network routing algorithms to find the most efficient route for data packets through a network. Resource allocation. A star search can be used in resource allocation problem such as task scheduling to find the optimal allocation of resources. Thank you.